In 2013, SpaceX announced that they were going to try landing their Falcon 9 rocket back on Earth. To add to the complexity of this idea, they were going to try landing on a floating drone ship in the middle of the ocean. Something like this had never been done before, and at the time it seemed like an impossible goal. But if it was successful, it would be a massive step forward for rocket reusability. So SpaceX began experimenting with various test vehicles to learn how to land a rocket. After a couple of years and many explosions, SpaceX finally made the impossible possible. 5 years on from that historic first landing, the iconic sight of a Falcon 9 landing has become routine. With so many launches nowadays, SpaceX have perfected this incredible feat of engineering and saved themselves a lot of money. Each time a Falcon 9 is reflown, they save on the cost of building a brand new booster. In just the last 5 years, this has saved SpaceX over $1.4 billion. To this day, SpaceX is the only company that has landed and reused an orbital rocket booster. But now they are focusing their efforts on Starship and the next evolution of crazy space ideas. Those of us who have followed the Starship program have been treated to some incredible spectacles. The recent SN8 test flight was one of the craziest things SpaceX have ever done, but it showed that their ambitious plans for Starship are more realistic than most of us thought. After all of the crazy things SpaceX have done over the last 5 years, it seemed like things couldn't get any crazier. Until this. On Twitter, Elon casually announced a new plan to land the Super Heavy booster. But the plan isn't to land Super Heavy at all. Instead, SpaceX wants to catch it out of the air as it makes its final approach over the launch mount.
It's an entirely different kind of flying, altogether.
It's an entirely different kind of flying.
Although this sounds like another crazy Elon idea, SpaceX aren't the only company to consider catching rockets out of the sky. Rocket Lab is planning on catching their Electron rocket using parachutes and a helicopter. Back in the 60s, NASA considered catching the enormous Saturn V first stage using a helicopter with rotor blades over 100 meters long. In comparison, SpaceX's idea sounds a little less crazy. So we have established how SpaceX are going to catch the Super Heavy booster, but in order to know why, we need to understand the overall goal of Starship. Starship consists of 2 stages, the booster stage called Super Heavy, and the second stage, which is just called Starship. Super Heavy lifts the second stage out of the thickest parts of the atmosphere, and Starship does the rest of the work to get into orbit. After separating, Super Heavy comes back down to land, just like the Falcon 9. For Starship, the aim is to travel to the Moon and Mars. In order to achieve this, SpaceX will use a fleet of Starships to refuel in space. On top of this, SpaceX also wants to use Starship for Earth-to-Earth passenger travel. This means Starship will need to perform multiple flights a day with a turnaround time on par with airliners. The original plan for Super Heavy was to land directly onto the launch mount, making it instantly ready for its next flight. Although this would have many benefits, it would require a level of precision much greater than SpaceX have shown with their Falcon 9 landings. So SpaceX moved to the idea of landing Super Heavy on a landing pad and using a giant crane to lift it onto the launch mount. This would require at least 6 extremely large landing legs with enough shock absorption to handle the landing. But this is where the problem comes in. For the Falcon 9 landings, the booster needs to be transported back to a refurbishment hangar where many components are replaced and inspected. One of the most critical parts in their refurbishment process is the landing legs. All of this takes an enormous amount of time, which isn't an option for Super Heavy. Removing the legs from the design completely would not only simplify the turnaround time, but it would also save an incredible amount of weight. Every kilogram of mass saved will allow the rocket to carry heavier payloads into orbit. With 6 legs on the Super Heavy, the overall mass of the landing gear would be around 10% of the entire booster upon landing. But without any legs, SpaceX's only option is to catch the booster. This will still require a great amount of precision, since the booster will need to hit its marks almost perfectly. But one of the big advantages Super Heavy has over the Falcon 9 is its ability to hover. Even with just one engine firing, the Falcon 9 is too powerful to hover, so it has to perform a suicide burn. This involves firing its engine at just the right time, bringing the vertical velocity to 0 the moment it touches the ground. Since Super Heavy has more engines than the Falcon 9, it can reduce its thrust-to-weight ratio to 1. This will allow it to hover over the pad and give it extra time to adjust its course. SpaceX will try to catch the booster on its final approach using a giant arm attached to the launch tower. As Super Heavy comes into land, it will thread the needle between these catching arms until they retract inwards and lock into place. One of the key points about this idea is that the catcher will hook onto the grid fins, which will need to take the load of the entire booster. At first, this seems like an incredible amount of force to exert on the grid fins, but since they are designed to handle a large amount of drag upon re-entry, they are already extremely strong in this direction. Despite this unique method of landing, it will still require shock absorption to handle the last bit of energy and bring the booster to a standstill. Normally, this shock absorption would be handled by the landing legs. On the Falcon 9, the landing legs consist of telescopic tubes that are filled with compressed helium. As the legs fold in on themselves, the compressed gas acts as a shock absorber to handle the last bit of energy. The main thing here is that the shock absorption will be built into the catcher and not the rocket. This will reduce the amount of stress on the rocket, taking away any need for major refurbishment. SpaceX will likely use a similar system of air suspension, but on a much larger scale. Another theory is that they could use a cable catching system, similar to the ones used on aircraft carriers. This system involves multiple steel ropes laid out on the runway, which are designed to be caught by the tail hook of an aircraft. As the hook connects with the wires, the energy is absorbed by hydraulic damping systems below the deck, quickly bringing it to a halt. Taking all of this away from the rocket and transferring it onto the landing arm will allow Super Heavy to be as light as possible, without putting too much stress on the rocket. But weight saving is only part of the puzzle. The real benefit here is the ability to rapidly relaunch the booster. If it can be immediately lowered onto the launch mount after a landing, the booster can be secured, detanked, and inspected for its next flight. After all, the detanking process is especially important for Starship since it will still contain excess methane after it lands. Methane isn't allowed to be vented into the atmosphere, so SpaceX plans to pump the leftovers back into the tank farm for it to be recondensed and used for the next flight. So, although we might have to wait a few more years for SpaceX to attempt this crazy idea, it's inspiring to see them taking on these incredible engineering challenges. When SpaceX landed their first booster 5 years ago, it made us rethink what is possible and advanced the world of spaceflight massively.